So, guys, what I wanted to do is, obviously there are two ways to deploy wireless LANs. Who loves controllers?
I do.
Okay, we got a half of the room. Who loves controllerless?
I do.
I like both. How about both? Who likes coffee and tea? Okay, good. Who likes chicken kebab and beef kebab? Okay, good. So that's the point, right? There are a couple of things to get rid of your thirst, get rid of your hunger, and a couple of ways to deploy wireless LANs, all right? So as I said, we've been doing this for the last, this guy right here, for the last 10 years. So the first generation APs, first generation controllers really focused on solving some of the problems that happen with autonomous APs, right? RF management, mobility, layer 3 mobility, go crazy, even do some fast roaming, right? A lot of new features. In the meantime, what happened was the data traffic flowing through the APs hit the controllers. That was kind of the solution. It helped with roaming, it helped with policy enforcement, etc. Over the years, we built more controllers. Lately, we came up with our third generation of controllers called 7200. That's what you have access to in the login information that you have in front of you. And then that's what Bala and Scott are going to do a little bit of talk on. What is that controller? What does that do? Show you a couple of things on the UI, see what you think. And then three years ago, Pradeep, which you have met before, our engineer and a couple other engineers started working on controllerless solution. The primary reason for that was once we look at the AP platforms, the stuff that we sell for $1,000 list, if you look at the memory and CPU specs of those platforms, they were very similar to the early generation controllers. So we basically started doing the right thing by the customer, and we said, okay, for certain locations where the wired infrastructure is already in place, and we don't need to take traffic from the access layer all the way to the data center. Not all networks are designed that way. Let's start building a controllerless Wi-Fi solution. So we believe that there's a place for both of these guys, both of these architectures, and we are supporting both. So there's feature parity among the controllers and controllerless. Our controller-based solutions runs Aruba OS, our 10-year-old control-based software. The same amount of image, we of course need to optimize it. We of course need to change a couple of things so that we can run it in a controllerless fashion. For example, the data plan needs to be distributed on all the APs, but the management plane needs to be, synchronized among access points. Instead of one controller talking to the APs, the management plane needs to be survivable, distributed among many APs. Mobility, same way. Firewall session state, same way, right? So that version of software is called Instant OS. So currently, we're running 6.2 version of software. That's the latest version that we have. 6.3 is coming up. And on the Instant APs, we have Instant 3.2, and 3.3 is coming up, 3.4. So there's all the documentation, feature set capabilities, et cetera, that are available on the support side. But I just wanted to make that clear, right? So the operating systems are separate, but there's feature parity among both.
Are there limitations at a licensing level then, or maybe not, maybe, for legitimate reasons in terms of seeking the memory, but in terms of the controllerless, how many APs can I do controllerless?
To be honest with the controllers, you can go, if you want 1,000 APs in a campus, go ahead, knock yourself out. The limitation, as I'm going to tell you, the network design at the end matters. You can enable a one instant cluster of APs among a single management VLAN. So let's say that you have 10 VLANs, you can build 10 instant clusters, and you can enable roaming between them, layer 3 roaming between them. As long as you're okay with that design, configure switches at the edge, manage different instant clusters in the campus, feel free to do it. Right? So there's no limitation really. But in a one VLAN discussion, we looked at several network designs. One instant cluster, how much can I scale that? At some point, VLANs need to be managed at a certain size, depending on the device count connected to the wireless network, depending on what other wired devices I have in that VLAN to serve up IP addresses. Usually we see that limit to be 50, 60 based on customer preference. Can you go to 100? You can.
Is it 50 APs in a cluster?
Yeah, you can go to that. You can go to 55. You can go to 60, 65. But at the end of the day, you know, at some point you're going to have to break that VLAN into different chunks so that you can actually manage the network.
Like most of VLAN limitations, or when people, you know, break a VLAN down, it's what was said as a best practice years ago, at least, was because of broadcast traffic.
Yeah.
Which is much less of an issue today than it was, you know, several years ago. So, I mean, 50 is pretty small for a VLAN.
Yeah. But that also includes the mobile devices, right? So the VLANs that the mobile devices get IP addresses from is also limited with one cluster.
So you're suggesting APs in the same VLAN as the clients then?
Yeah. Assume that there's APs, mobile devices, wired networking gear at the edge of the network served up by that same VLAN. How far do you want to take that VLAN size to?
So
for us, there's no preference.
Are you recommending generally that APs are in the same VLANs as clients?
It doesn't have to be. Management VLAN can be
If
separate.
the APs are an AP management VLAN or a network management, what size can you go to then?
So if you have a management VLAN for the APs, and if you have a client VLAN for the devices, still the client VLAN needs to be one VLAN for one instant cluster. Does that make sense?
Sure. So if you had a large number, like a high density of APs, but not necessarily a large number of clients, you could still then put 200 APs in that cluster, even if you only have 200 clients, which I've seen often, particularly, you know, I've done country installs. You need a high density for location and voice. So
Absolutely.
you've got a large number of APs, but they're still small active sites.
There you go.
So that's fine.
Yeah. Proper, I mean, this is just proper layer 2, layer 3 network design. So where do you break the boundary between layer 2 and layer 3 roaming? It just depends on how you want to design the network. Right? Okay, so a couple of things here. So controllerless network integration, a lot of us know this, but essentially we'll look at APs operate as clusters. Let's say that those are two separate management VLANs, user VLANs, etc. I say with redundancy because, you know, instant APs, as Dave and Neil are going to talk to you, there's a built-in survivability there, right? So if one of the APs go down, another AP assumes the role of cluster management and talking to the airwave. You know, airwave manages all these clusters across distributed locations or in one campus, and one of those APs have an HTTPS connection back to airwave for reporting. If that AP goes down, another AP assumes that responsibility, right? So this is a distributed management plane across the APs, right? Then you have that AP selection. As I said, it's dynamic. The biggest difference is you have, in a campus environment, you have a lot of these access switches, right? In a branch, you probably have few. The VLANs, where the users are getting their IP addresses, lives at the access layer. Wireless users get their IP address from the access layer, right? So that's a big difference compared to a controller-based architecture. And management server for instant UI, you don't necessarily need it. If you want to use Airwave, you can, but the instant APs come with a built-in management UI, which you're going to log in and experience, and I believe many of you already have instant APs. Okay, so if you look at the number of APs, this is kind of what we just talked about. Number of APs, Wi-Fi users per controllerless group, per controllerless cluster, really depends on your VLAN sizing, how your existing wired network is, how you want to add wireless network users, etc. Right? Any questions on the controllerless network integration? Again, so this can expand to a big campus, or this can shrink into a small branch, your choice. All right. Now, controllers, we have done this many times. The AP VLANs stay at the access. The Wi-Fi user VLANs stay at the core. That's really the biggest difference, right? So if you look at how am I going to design my layer 2, layer 3 network, my user VLANs attached to the controller. If I want to create a new SSID or add more VLANs to the same SSID, I do it here and here. I don't go to my access switches, right? But the APs use the existing VLANs. Our recommendation is to use the existing VLANs for the APs because they're just another wired device. The traffic flows through the controller to the data center, back out to the core, wherever it needs to go. Right? So that's the biggest difference. We have, broadcast, multicast controllers there, etc. And the group of APs, group of Wi-Fi users, how many of that really depends on the mobility controller. You buy a small controller, you go up to 1,000 users. You buy a bigger controller, you go up to 30,000 users. Right? It depends on the scale. So both models, again, we support. Where we see the attraction for controllerless, usually K-12 branch, retail branch, they love the controllerless option. And there, for a while, before we came up with the controllerless, we had this design where the controllers would manage the wraps. Remember that? Cisco calls that flex architecture today. We believe that flex architecture, or the one controller managing multiple wraps at a remote site, not the best idea. I would love to hear what you think, but we compared the list price of Cisco Flex managing 32,000 APs. Again, this is a stretch, right? 32,000 APs, and building the same infrastructure with Instant, right? And if you need back-end VPN services from an Instant, because Instant can support site-to-site VPN, let's assume that we need that too. We compared Flex controller cost to how we should do it in the Aruba way. There's a big list price difference, right? So that's the value that we want to bring. Our recommendation, 99% of our recommendations will be either controllerless, managed by Airwave, or controller-based in the campus. We no longer recommend a lot of APs in the branch managed by some controller appliance in the data center, because there's a lot of functions gets lost when you have a WAN failure, the roaming doesn't really work that well, guest access happens centrally instead of distributed, so there's all this negative things going on.
So you're saying controllerless managed by Airwave, so essentially it is literally not even hundreds of sites going back to a large controller, but data local.
Yep.
It is, there is a controller, but it's sitting in those APs.
Those APs, yeah. So it gets distributed. And if you draw the map, you will see that the data plane and the control plane, at that point, if you go with the controller's design, gets to individual sites that are completely remote, and only management plane lives in the data center. If you go with a flex type architecture or remote AP architecture for the branch, for retail stores for K-12, then you kind of distribute control plane, data plane between different locations, and you just can't keep up with feature sets. Like guest access becomes a big problem, Layer 3 mobility becomes a big problem, monitoring becomes a big problem, survivability in case of WAN failures becomes a big problem, etc. So
essentially the controller that's living in the access point, presumably that's in your most powerful model AP. Your newer AP is going to have more RAM or CPU. How does that work?
Pretty much. Today we're able to support uniformly across the board all the features, but coming up with 11 AC APs with more CPU, more memory, of course, is going to help. But today I think we're already there. We recommend deploying a lot of large-scale controllerless wireless network across branch offices. That's where it seems to be the biggest attraction point. And to be honest with you, for the controllerless design, there's certain aspects that resembles autonomous AP design. It's not exactly the same, but it's very similar, right? So if you're already familiar with supporting an autonomous AP wireless design, and you want to migrate to the next grade technology like 11N, 11AC, we tend to see that it's easier to switch from that model to the controllerless design, because putting a controller in a data center automatically forces people to change their network design, and they don't seem to like that. So there's that aspect of it too.
If you're supporting a large number of home users, like with the little wrap AP, does that change your conversation any? Because those obviously aren't instant AP capable.
Not at all. So For the home offices, 1 or 2 AP locations, wraps, big hit. Love it, right? So
Still recommend a controller at the head end.
absolutely, because at that point, you basically have a VPN connectivity that needs to go back to the controller, and there's some zero-touch provisioning features that Instant also has, but wrap also needs. There's a lot of data forwarding that you can do on the AP. That wrap model is supported, and the good thing is all our APs that, at least the last generation of APs over the year, have an instant capability, wrap capability, and campus AP capability within. And Dave actually is going to talk about this a little bit more, how you can provision them from the cloud so that you just deploy the AP and then you can software define it along the way. Right, so if you want to deploy it as a wrap, directly talking to a controller, managed by a controller, or leave it as an instant AP, only doing VPN, site-to-site VPN, it's your choice. But a wrap deployment model is still very hot, it's still very attractive. It's just that if you start deploying 10, 20 wraps at a branch, stop doing that, go to instant.
So in effect, you've come as a hybrid model into where you've kind of got some functionalities, like say a centralized guest server back at corporate to authenticate your guests that you're tunneling back across to the corporate, and then the rest of it you're using the IAP to manage locally the authentication for users.
Pretty much. Yeah, I mean, if you're using instant AP at that point, your authenticator is the instant AP cluster. Whoever's managed that instant AP, that specific instant AP goes to the authentication server and says, hey, I have users to authenticate. If the controller is in the picture and managing the APs, either as a remote AP or a campus AP, then controller assumes the responsibility of the authenticator. Does that make sense? Okay, so at the end of the day, there's a couple of ways you can extend the network, right? So this is the picture of a mixed architecture. In the campus, you have a lot of centralized security services, your DHCP radius, AD, everything is centralized. And you know what, you prefer a controller-based architecture. Same controller or the same controller cluster supports different branch offices. Those instant APs can VPN back in. They are not downloading their configuration from the controller, it's just that they route traffic from the branch offices to here using VPN. That's perfectly doable too. And at the back end, you have Airwave to manage both.
So Airwave, you wouldn't manage the instant APs through the controller at all?
Not at all. It's just Airwave.
Just immediately a VPN endpoint or something?
VPN endpoint can be the controller, that's correct. And of course, we have seen this a lot where the customers start with an instant AP design. For whatever reason, they prefer to use the same infrastructure and move some of the APs to a controller-based design, either as a remote AP or either as a campus AP. So obviously the APs have multiple personalities, as we said. So you add the controller in the network, you go to the instant cluster in the instant AP and you say, here's the controller, let's convert it to a controller-based design. All of a sudden they become that centralized wireless LAN. Down the road, you change your mind, you want to bring them back to an instant AP, you can do that. Right, so it's back and forth, again, software-defined, same hardware. So overall, we recommend to our customers to ask certain questions. Hey, you saw the benefits of controllers, controllerless. Let's define in which locations you want to go with which design, right? And what do you want to use? For your controllers, some characteristics like centralized encryption becomes important in finance, maybe healthcare, government is huge centralized encryption fans, policy enforcement. And do you want to do local or centralized switching at the same time? Where does that live? How is your routing policy defined? Can your controllers APs, there's no controller to deploy hundreds of these things. So how do you do the initial provisioning of these things? So it has to be done from Airwave, but they need to find Airwave first. So we're actually going to demonstrate that to you guys. So there's some cloud-based provisioning capabilities that we built. And can I go back and forth and mix it, right? Again, the whole idea is wireless has to be pervasive. we need to reach an end. The end goal is whatever the customer defines the end goal is. I want my voice to be on wireless network. They don't start the discussion with saying, I want to buy APs. They saying, hey, I bought a lot of iPads, I need a good Wi-Fi. So we just basically create many means for them to reach that end, right? So for us, the wireless LAN gear is just a means to the end. As long as they're happy with the performance, we're good, okay? It's their choice at the end to define how the network is built. So, yeah.
What do you think the drive is for vendors? Because in the last year, seems to be a massive drive to even VMware-based or more of a controller, local data plane architecture, and it's been there before with Cisco, Aruba, I'm sure, and others. What is the driver, you think?
Yeah, I mean, to be honest with you, that intermediate VM-based controller appliance is kind of redundant. I mean, you can do the stuff on the APs, and then you can collect the information on Airwave, push configuration, get monitoring data.
So coming out that sort of being released now, or, I mean, I think Blue Socket had something a while ago, but
Yeah.
Cisco, Juniper, you know, it's sort of being released at the same time as vendors are also going controllerless, like you say, so it's maybe it's something that needed to be here a couple of years ago in terms of VM, but I guess more the question is from just what is driving vendors to controllerless? Is it customers demanding it?
Absolutely. One is the technology availability. So we have chosen to build that architecture because we saw the fact that, hey, we can actually do it. Customers not everybody wants centralized data forwarding. And not everybody wants to design the network based on a controller and how the traffic flows, given the fact that we work with many customers. So we started to go that route. VM-based controllers, why do it if they're not going to do anything else but manage the APs? As long as the APs can manage themselves, that's fully distributed, that's perfectly fine. So I think there's a need to accommodate different forwarding patterns, different set of applications, different set of locations, different set of wired and wireless network design. Our approach has been, let's make the AP smart, let's make the AP survivable. And I think some people chose the approach of, okay, I need to locally forward data. How am I going to do that? Oh, let's take controller functions and put them in a VM, make it low cost, and then let APs do some local forwarding. We chose not to go that route. I think, it's kind of a preference thing. We think that there should be no middleman if you're really truly doing distributed. And I think Kirti has.
I can't.
I know.
So I think controllerless, just from a evolution perspective, if you think about where it started, to us, we first learned about the requirement when we were pitching controller based, probably back in 2006, where the customer said, I want to deploy an AP across the internet, and for a branch office or home office, and I don't want to deploy a controller. Could we leverage your control plane in the controller and manage the access point and shift the data plane over to the AP? And we called it a RAP, remote APs, and they're quite popular, mostly used for telecommuters and so on. What we learned was through that process, the RAP initially was a telecommuter product, single AP product, and then a retailer started to pick that up. We had, and this is not big box retailers, these were smaller stores where you needed more than one access point, but still a handful, maybe 5, 6 access points at the most. And they all basically said, we don't have much complexity in the wireless LAN. We have maybe a couple of VLANs, maybe a couple of SSIDs. So I'll just add a few remote APs and connect them to the local switch. You can take your firewall functionality, which is the heart of what Aruba does, and put it inside the access points and still control it from that central location. That'll give us what we need. And we have quite a few deployments done that way. And the next logical question that comes from that is what happens when that link to the WAN goes down? Can you survive? And then we started to add a bunch of survivability features to the RAP. And eventually decided, hey, let's take as much of the controller that we can, put it in there and make it a self-organizing sort of an autonomous system that can still report back to a management platform like Airwave. And that was the sort of evolution curve of how Instant came to be. You'll find later, we are actually now
taking the controller and the controllerless models and bringing them back together, because we think, especially for large scale, carrier scale kind of networks, those things will start to need to come together again. I think we're going to talk more about that as well. The VMware question is an interesting one as well. If you, again, take a look at a controller, it has 3 planes, right? The control, management, and data planes. If you don't need the performance of a network processor, and you want the convenience of, I have a VM, I'm going to load it and run a few access points through it, an Intel processor can do just fine running on a VM. It won't scale a whole lot, but you can have a controller run on a VM. We have not taken that path because, as Ozer said, to us, you either are building large-scale campus networks where a real controller with a real data plane processor is important, and we've chosen the path of network processors for that. Or you're in the branch office type scenario where you don't need a physical controller, you can do it with an AP. Having said that, I think if you think about where we're going to be 2-3 years from now, Intel is adding quite a bit of smarts to their processor architecture for a data plane, which they have not been good at. They're very good at control plane and management, but data plane has not been their strength. But I expect that to change quite a bit. They're adding 40 gig crypto, a lot of custom instructions for network processors. And so I think x86 based architectures will make their way back into what the controller does today. It's just not here right now, but I think the next generation of controllers, I think, will move in that direction.
So Kirti, when do you see it's more appropriate to use a controller-based architecture versus an IoT? Is that a size discussion or a centralized campus type discussion?
Yeah, so if you were to boil it down, a lot of times with customers, it's a size discussion. It comes down to, how large do you want to make your mobility domain more than anything else? And if you want to live with a flat network, how much layer 3 mobility is there? And the more there is, the better off the controllers are. The second aspect that comes out quite often is security. And there, because but I think we and Moto are probably the only guys that do crypto in the controller. So that kind of helps you basically say the intervening network is simply a transport and not doing anything from a security perspective. And for the security conscious customers, financial services, government, hospitals, HIPAA compliance, if that's an issue, that consideration becomes quite important. So those two are the toss-ups. Other than that, we've really tried very hard to take as much of the controller and make it available on the virtual controller as well.
Is there much of a TCO difference between the two architectures? There's a big piece of hardware on one side and not on the other.
Right.
And that you made the decision seem like it was, oh yeah, we did this or this.
Yeah, there is. Actually, so I'm glad you used the word TCO. It's an overused term in the industry, but here is the thing, right? When you have a large network, a large number of subnets, a lot of mobility inside the network, it's not just the cost of the hardware that you put at the edge or in the core. It's what do you need to do to the network to make it all work together. How many VLANs do you need to add? How many switches do you need to go configure to add those VLANs in? How do you then internetwork them together? How many DHCP scopes do I need to add at the back for wireless? All that begins to add up from an operational cost perspective. And I think the other question is the simplicity, right? If you can say it's beginning to scale, I have too many touch points out there. If I can make it simple, this was the old controller argument, right? If you can make it a simple overlay, so I don't have to really disrupt my backbone, if you will, the access and the core, and create wireless as an overlay on top, there's a huge operational benefit to that. And that is a judgment call, right? Some customers will say, I'll take that hit, I'm going to go configure all my switches with edge VLANs and build out a controller-less architecture because it costs less and I can only afford so much. Or I'm not willing to take the hit, I want to centralize my operations so that my operational burden is much simpler. Very rarely is it a data plane question on the controller. Can your controller keep up? Is it a performance bottleneck, etc.? Those things are more, I find that to be more vendor-to-vendor FUD than real customer barriers.
Well, and that's why I ask, because it seems like you have some costs that come with controllerless that you don't have with controller.
Right.
And And so in TCO, are they closer than they seem? Is kind of the question.
I mean, it's, as I said, depending on, at some point, they will be closer than they seem. And even in the branch case, if you start to go to a larger branch office, like a large grocery store, big box retail, controllers will be a good fit there, right? It really depends. To me, I look at how much change do you need to make to the intervening network. And if there's a lot of change and that gets multiplied by 1,000 stores, if you have those, then the OpEx will be extremely high. So simplifying that makes a lot of sense in that
Nice
situation.
matrix would help.
Yeah, that's a good feedback. Okay, on to the next topic.
So